Alrighty, welcome to day 4 of Mars Week. So today we're going to talk about how can we terraform Mars. So as we're actually going on with the week, we're talking about terraforming Mars and eventually living on Mars one day. And there's going to be some positives for a little bit, and then we're going to talk about the cons, the negatives. So during this video, there's going to be some uh, pros and there's going to be some cons as I react to this video, and I'm going to share them with you guys. So without further ado, we're going to check out a channel called Futurology, and this is a video called How to Terraform Mars. So without further ado, let's check it out. So I'm going to put the original link in the description down below. Without further ado, let's talk about it.
Mars can be terraformed into an Earth-like paradise. Billions of years ago, Mars had a magnetic field and an atmosphere of similar density to Earth's today. Its temperature was above freezing, and it contained massive amounts of surface water, which formed the ocean covering the planet's northern hemisphere. There was a climate and maybe even life. However, around 4 billion years ago, the convection in Mars' iron core, which generated its magnetic field, shut down. With no magnetic field.
Yeah, so pretty much Mars is smaller than Earth, and Mars couldn't really keep all its heat convected through. So pretty much when you have a core that's smaller, it can't really produce as much heat that compared to the Earth. Earth can withstand all this heat. That's why Earth's core is hotter than the surface of the sun. But Mars, on the other hand, it's smaller. The gravity is weaker, so the core itself is a lot smaller. So it didn't have enough convection and heat to convect. So that's why it got colder really quick. So it solidified. So it lost all of its charge. Eventually, the magnetic field it still has is a lot weaker than it used to have, than what it used to have back in its early time. So that's why all the solar flares stripped a lot of its atmosphere because there wasn't any protection to keep the liquid water running, the atmosphere running. So yeah.
Collecting charged particles, Mars' atmosphere was all of a sudden exposed to the solar wind.
Yep.
Over the next several billion years, solar wind particles slowly stripped Mars' atmosphere. With no insulation, temperatures plunged. All water either froze or slowly escaped through the atmosphere.
True.
Because of this, we are now left with the Mars of today.
So some of the water has been locked out as just ice on the polar ice caps.
A freezing, dusty wasteland. However, it is possible to terraform Mars back into a habitable planet. With this comes many obstacles.
Yeah.
The first is re-establishing a magnetic field to protect Mars. Several ideas have been introduced to fix this problem. The most promising is probably the magnetic shield concept. Between the Sun and Mars, there is a special point called Lagrange point 1, where the gravitational attraction between the Sun and Mars cancels out. Therefore, anything that is put there will stay in equilibrium between the two bodies.
There you go. So pretty much if you connect a magnetic pole on its north pole and its south pole, and you create these wires, so a one positive and one negative. So pretty much you can conduct heat through the pole itself, and then eventually, once you conduct the heat, and eventually you release these electrons, these ions. So pretty much it creates this field. So you have your first basics of your magnetic field. It's kind of similar to the first episode of Phineas and Ferb, where Doofenshmirtz creates this magnifinator, and he connects it by this magnetic poles, and there's this magnetic tube that goes through it, and pretty much he does it. So basically, what he wants to do is kind of strip the buildings on the eastern seaboard off its foundation, and then put it on the other side where it reverse the rotation of the Earth. And don't know why he wants to do this, but I mean, tinfoil alone costs a lot. So pretty much, so he builds this. And actually, if you look at film theorist with Matt Pat, wish MatPat was back. I remember MatPat. So yeah, so MatPat talks about on the film theories about the Phineas and Ferb thing, where he creates this on a closed system. It's where it's localized. If you do it on an open system, it's you're more spread out. You have this whole area to set up this magnetic field on Mars. So it's just a simple of between a closed system and a open system. And also, you mentioned that Deuce plan failed in the first place because the tinfoil alone is not magnetic. So that's one downside of that scheme. That's why this tinfoil ball coalesced and formed this 2 ton tinfoil ball that's traveling 200 miles per hour and crushed him. So pretty much that's what really failed because most buildings, like most skyscrapers, are steel and are mostly steel, and they are magnetic. Steel and iron, they're magnetic. So reheating the core as well, um, it's not currently feasible. But if we can drill right through and we create some friction, but right now it's not feasible. So the cheaper way is to pretty much create these poles, these magnificators or something, these magnetic poles, put wires through them, and then you create your basic magnetic field, basically.
By placing an inflatable magnetic dipole with a field strength of 1 to 2 Tesla at this
There you go.
point, we would create a magnetic field that would deflect solar wind particles far enough to shield the entirety of Mars.
Mhm.
By simply adding this shield, researchers have predicted that a greenhouse effect would begin on Mars
There you go.
over millions of
Basically, the magnetic field is blocking out all this radiation that's penetrating Mars.
years. This would increase the planet's temperature by
There you
about 7 degrees Celsius, facilitating the melting of Mars' polar ice. Eventually, 1/7 of the planet's former oceans would be restored. While protecting Mars from the solar wind would be a huge feat, we could do much more to speed up the terraforming process. Currently, Mars has an atmospheric pressure of around 0.006 bars,
go.
compared to Earth's 1 bar at sea level. Many ideas have been proposed to thicken it. Mars has two polar ice caps composed of both water ice and frozen carbon
There you
dioxide,
go.
or dry ice. If
Like
we
I mentioned, so all that water was evaporated into space. The water on the caps are just leftover water remnants that were locked in as ice as the planet got colder.
release large amounts of short lived but extremely powerful greenhouse gases, such as chlorofluorocarbons, this would lead to a temporary greenhouse effect. The heating from this would turn some of the polar ice caps into gas. This gas would add to the greenhouse effect,
There you go.
raising temperatures and causing more
Basically,
ice to become
millibars.
gas. Eventually, all of the ice would turn into atmosphere, doubling the planet's
There
atmospheric
you go.
pressure. This process would require around 39 million tons of chlorofluorocarbons, 3 times the amount produced on Earth between 1972 and 1992. This amount could be produced on Mars in nuclear powered factories with local materials. In addition to vaporizing ice caps, if Mars' regolith was heated, the CO2 attached to it would eventually be released. This would add about 0.04 bars of pressure, a major increase. Lastly, shallow carbon bearing minerals and ice clathrates could be mined and heated, releasing another 0.017 bars of pressure. With all these methods, Mars' atmosphere could be heated enough to allow for the presence of liquid water.
There you go.
There would be weather and a global ocean covering
Yeah, so you created your water cycle now. You have all this ocean now. There you go.
the northern hemisphere. Still, though, Mars would be far from habitable.
Yep. So far.
All this would increase the pressure to only 6.9% of Earth's. To raise this level, it's been hypothesized that carbon bearing minerals deep in the crust could be mined and heated. This could raise pressure levels up to 1 bar. However, currently, the quantity of these minerals is unknown, and this process would be
Yep. So pretty much as you strike gold, pretty much in the mining industry, where you strike some precious minerals, and you have all of these people that want this mineral, and because it's easily profitable. So if you have a city, like a mountain town that's relying on an old mountain town that used to be a bustling town back, let's say, in the late 1800s or so. They would used to strike gold because their economy was mining. So basically, they were mining from gold, silver, a lot of that stuff. And then eventually, the reason why most ghost towns dwindled, well, and from Colorado's sake, like there's St. Elmo, there's Tin Cup, there's other. We have a lot of ghost towns around Colorado, and most of those are in the mountains. So pretty much all those mountains, those little mountain ghost towns, they were pretty much gold and silver boomers. So eventually, the supply and demand, people wanted to make things out of silver and or gold or something because that's a very easy profit. So once they keep mining, but there's nothing there, they they struck everything. They got everything they wanted, and now there's nothing there. So now there's no money, and then that means your town population dwindles because they couldn't sustain their economy anymore. So people are now losing a lot of money. So to get opportunity, they would have to go somewhere different, go nearby towns that are starting and nearby businesses. So pretty much all of that stuff, like gold and silver, has been depleted. So on Mars, it's going to be the similar thing where all these minerals that you're saving on, relying on for Mars to save it, again, you still have the supply and demand over here. So pretty much once you leave that stuff out, then you're pretty much doomed because that's what you're relying on now. And without supply and demand, now you're it's depleted now. Then you're just abandoned ship.
Incredibly difficult. Another solution is diverting ammonia rich comets in the
Yep.
outer solar system to
So the late heavy bombardment period.
collide with Mars. This ammonia would quickly break down into hydrogen
Let's call that a term early on called panspermia. Pretty much during the late heavy bombardment period where there was like water, it had salts, it had minerals, it had bacteria, you had all this life inside of these comets that brought down to Venus, Earth, and Mars. And eventually, they created and then formed. Bacteria formed into these algae and these minerals that formed as like stromatolites.
and nitrogen, thickening the atmosphere.
And similar to that, so Earth right now is composed of 78% nitrogen, 21% oxygen, and traces of argon, so only like 1%, and a few other little bits of gases here and there.
Lastly, we could import hydrocarbons or carbon dioxide from Earth, Venus, or Saturn's moon Titan.
Like I said yesterday's video, we can take a little, like almost like a little vacuum thing. We can take a little piece of atmosphere from Venus and then we can put it on Mars, and then we can trap in a little bit of heat and kind of insulate it.
These combined sources could get Mars' atmosphere up to 1 bar. People would be able to walk on Mars' surface with no pressure suit and would only need a mask providing breathable
Yeah.
air. But this is not enough. We want a breathable atmosphere.
Yeah, and this is a word, like I said, you need a lot more money and you need a lot more time.
At this point, Mars' atmosphere would be primarily carbon dioxide. However, for humans, breathing any atmosphere over 1% carbon dioxide would cause drowsiness, and anything over 10% would likely mean death. To reduce the concentration of carbon dioxide while increasing oxygen, Mars will go green.
Yep. So a lot of trees. You need to plant a lot of trees because, like I said, well, not a lot of trees be planted in different locations, like different latitudes. There's like if you're on the equator, like palm trees and um, other like flora and faunas. But if you look on the tundra, they have like these pine trees and many little shrubs that can only survive in cold temperatures.
Right now, Martian soil has about a 0.5% concentration of perchlorate, which is toxic to humans. In fact, it will provide a major health threat for early astronauts. However, some bacteria naturally consume perchlorate. These bacteria, combined with filtering systems, can eliminate the toxic chemical. Meanwhile, we can release microbes and mosses around the planet. These will spread, making healthy soil while turning carbon dioxide into oxygen.
There you go.
During this
You just created photos, kind of did some photosynthesis over here.
time, ozone will also be
Yes, ozone. So pretty much ozone, this little blanket layer, and pretty much when the oxygen meets the sun's rays, and then you create this ozone. You create ozone.
mass produced to establish an artificial ozone layer.
There you go.
Slowly, larger plants will be incorporated into the environment. Fertilizer will help lighten and enrich the soil. However, due to the relatively low light levels on Mars, only certain plants will be able to survive. Gradually, Martian forests, grasslands, coral reefs, and other habitats will develop. Farmland will be established, growing food for humanity's expanding interplanetary population.
Hmm.
And finally, after adjusting it to perfection, the Martian atmosphere will be breathable. Over millions of years, due to Mars' small size and therefore minimal escape velocity,
Yep.
some of this atmosphere
Like I said, Earth is so yeah. Mars is smaller than Earth, so you only have a limited time to enjoy breathable air on Mars because due to its escape velocity, then it's gonna
will slowly
Earth.
escape. However, occasional resource imports will manage this. With everything in place,
And again, takes time and money.
animals will be released into the wild, and millions will emigrate to the planet. Still, though, life on terraformed Mars would be very different from Earth. The gravity would be only 38% of Earth's, which local populations would have to adjust to. In addition, each Martian day would be 24 hours and 37 minutes
So that's one soul.
long, and each year would be 687 days
So this is over double the 365 days here on Earth.
long. Also, there would be a lot less light than Earth, and with no major moon, there would be no tides. Since Mars has a similar tilt to Earth, there would still be seasons. However, because Mars has a much more elliptical orbit around the Sun, these seasons would be much more erratic.
So yeah, your seasons on Mars will last a little bit longer than Earth.
With no mountain chains and almost all the water in one hemisphere, the planet's climate would be very different from Earth's. Furthermore, a lack of plate tectonics would mean no recycling of carbon, water, or land over millions of years. On the positive side, though, there would be no earthquakes, volcanoes, or tsunamis. However, there would likely still be huge dust storms.
So
Lastly, the livable area would be much smaller than Earth's. Mars has only 28% of Earth's surface area. In review, terraforming
did you know that if you actually place Mars, it can pretty much like yeah, kind of like cover like if you put Mars in the Pacific Ocean, it will cover some of it, but the Pacific Ocean is bigger. So if you submerge Mars, it still would sink and be submerged. So it can fit in there, but the Pacific Ocean is much bigger.
Mars is certainly possible. However, it would take hundreds or even thousands of years and would require technology and megaprojects beyond humanity's current capabilities.
Yeah, pretty much. Yes, with all the technology that you have right now, this is still like not the technology that's going to be happening once we get to Mars because we still on the kind of the basics of stuff, but we are advancing. It's just the technology right now that we have is not feasible to take this to another planet and eventually we can terraform it because again, yeah, well, this project alone will take hundreds, if not thousands, of years, and so much money that needs to be contributed to that. And
Right now, we should just focus on protecting Earth.
yes, that's what we need to do better. We need to, you know, help Earth, and then we have bigger fish to fry on Earth. I mean, we are worried about Mars, one day, living on Mars one day, but we care about what's the bigger fish to fly, bigger fish to fry on Earth, climate wise and lots of other things.
What do you think? Will humanity eventually terraform Mars? Let's talk about it in the comments below. If you enjoyed,
I don't know. That's up to you guys. So give me some questions in the comments down below about Mars Week and all that stuff. If you have your opinions, if you have your questions or your pros and cons, let me know. And I'll see you guys in the next video. Share this with your friends and family. Will they ever live on Mars? Let me know. I'll see you guys next video. Bye.